are there situations where you might want to use both a mathematical optimizer and machine learning together?
Yeah, I mean, there's three ways that we sort of view the relationship between machine learning and optimization. One is all of those costs, time, travel times that we're talking about, all of those parameters. The best way to understand those or to know what those are is through machine learning, is through taking all of your data and coming up with those point estimates for all of those things. And the best way to do that is all of the awesome machine learning tools that we have available to us. Um, and then taking those predictions, so thinking like a demand forecast for your products in certain locations. I could say I have a pair of shoes, that is going to be very popular here, maybe not so much popular here, and things like that. Um, that is, building out those numerical forecasts. Okay, great. Um, but then when it comes to the acting on that and deciding, okay, here's how I should produce them. Here's where I should acquire you know, the bits and pieces to make them. And then here's the number that I should take from this production facility to this warehouse and this warehouse to this store, and all of those other combinations of things. That's that's where mathematical optimization shines, is because you can then define all of those decisions very explicitly. The number of shoes I'm going to produce of this type at this facility, and then ship them to this warehouse, and then this warehouse should then distribute them to these stores. You can have decision variables that talk about all of that, and then you fill in your constraints and say, okay, well, I only have this much of this much budget to buy certain things to manufacture the shoes. So there's some of my limitations right there. Or again, like going back to the trucks thing, I only have a certain amount of trucks or a certain amount of drivers, or things like that. That have all these business roles into them, which are all of your constraints. So yeah, that's essentially one of the main differences is, again, thinking and acting. Um, the 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 machine learning helps you think about where your demand is going to be hottest, of what types, but then actually acting on it is just something that machine learning doesn't do well, because part of it is machine learning. You need to have seen, you know, you need to have previously seen the outcome for it to be in your data set. And that's just not the right way of thinking about this. You need to explore all possibilities, and that's what mathematical optimization and a solver does. Is it helps you explore that 3D figure, helps you explore all of those possible solutions. And again, it's just different tools solving different problems, but one way that they can work together is like that. The second way is, as you mentioned at the sort of at the very beginning, is that actually machine learning problems are optimization problems. You are minimizing a cost function, so you can formulate problems like that, and regression is one example. And actually, we have a couple notebook examples. One is using mathematical optimization to switch up your objective. Your objective of linear regression is minimizing the sum of the squared errors. Um, what if you wanted to do absolute error? Like, oh, okay. Well, there's no calculus to help you there, or anything like that. So you could then model that in an optimization problem, and then also maybe guarantee other things like, hey, I want this set of regression coefficients to make sure that they're non-decreasing, because it may make sense for this tier of product or something, or and then I want my beta 1 to be less than beta 2, less than beta 3, so on. That's something that you can't do as well in with machine learning, at least not very directly. You'd have to maybe add some stuff. Um, and then another example is feature selection. We have an example that treats features sort of as binary variables in a sense. Do I want to include them? Yes. Is that value 1, or no? Is it 0? So on-off switch to help you figure out what's the best subset of features if you want to only include a certain number or something like that. So that's another way that optimization can be used with machine learning. And there's also optimal decision trees and stuff like that. So there's a whole bunch of ways to go about it. The third way is sort of the other way around, is embedding, and this is something that we recently released an open source package for, which is I'm super excited about this, is taking a trained regression model, something in scikit-learn or XGBoost, and embedding that into a larger optimization model. So if you have that sort of price demand relationship, then you can use that. You can use XGBoost to train that relationship of, if in this area with these other things, if I set my price to be this, my demand, I'm expecting my demand to be that. You can directly embed that into a larger optimization model that takes into consideration like your whole supply chain as well. So it's a really cool way to leverage mathematical optimization with with machine learning.